Hello, good morning, everyone. Welcome to the Imagery webinar series brought to you by S3 India. I am Lavinia, an engineer at S3 India working in Imagery domain. Today, we are going to discuss about and talk some amazing geoprocessing capabilities of, ArcGIS Pro in the imagery domain. How it is able to handle different types of imagery and what are the imagery solutions that ArcGIS can provide. So before delving into that, first I would like to highlight about Esri. Esri is a global leader in GIS and location services, and it is deployed in globally in more than 3 lakh organizations. And Esri spends most of its revenue in 30% of its revenue on R&D. And S3 India is a leading provider of geographic information system software in India, which was established in 1996 and headquartered in Delhi NCR. So, talking about today's agenda, first we will talk about ArcGIS, how it is a comprehensive imagery system. Another, how enhancing the visualization and exploitation with the ArcGIS Pro, working with the mosaic datasets, multidimensional imagery, and some popular image analysis approaches that we have in ArcGIS Pro, and advanced image analysis using deep learning, full motion video in ArcGIS Pro, and SAR capabilities in ArcGIS Pro. So, talking about the comprehensive system, ArcGIS today is a comprehensive system as it supports all aspects of imagery lifecycle from image capture through to visualization. ArcGIS allow us to create GIS-ready products with reality soup, and it has hundreds of tools to analyze and exploit imagery both on desktop and web. One can also visualize the imagery with your existing data on mobile, desktop, and web platforms in 2D, 3D, and even through the time. Finally, S3 has a lot of imagery content. So in addition to your data, the ArcGIS Living Atlas provides image base maps and catalogs of the past and the present imagery, such as Landsat series. So what is ArcGIS Image? So ArcGIS Image is a product suite that includes ArcGIS Reality, ArcGIS Pro and Image Analyst extension, which comes with the ArcGIS Pro, ArcGIS Image Server, ArcGIS Image for Online, and ArcGIS Image dedicated as a platform, as a service. And this enables one segment of the ArcGIS imagery capability as a part of the ArcGIS system. Now, talking about the enhanced image visualization and exploitation with the ArcGIS Pro, we have this is enabled with the help of the Image Analyst extension that we have in ArcGIS Pro, and it helps us to image interpretation and exploitations, and also in change detection and multidimensional data analysis. Motion imagery, where we use MISB compliant motion videos, and also stereo pairs, dealing with the stereo pairs and different sensor perspective using like perspective imagery or oriented imagery is also possible. Along with that, we also have deep learning capabilities with the help of ArcGIS Pro Image Analyst extension, and pixel editor capabilities and SAR capabilities, and also some specialized raster functions which are available for the on-the-fly processes. So working with the mosaic datasets. So now, what do we understand by the mosaic datasets? Is it the mosaic that we think about, like stitching of images? Well, that is wrong. Mosaic dataset is not the mosaicing as we see in a conventional, GIS terminologies. Mosaic datasets is just a virtual mosaicing of different types of imagery raster, be it from different sensors, be it from different resolution, be from different types of sensors. Say one is DEM, another is multispectral, another is net CDF5. So in this way, you can make a mosaic, virtual mosaic of all the different types of imagery that you have. So this helps in providing optimal data model for management of imagery and raster, and thus it is called the foundation or the heart of the image management solution. So, like as I said, it can be multi-sensors, multi-resolution, and multi-band. So it helps in manage, display, analyze, serve, and share imagery and raster data. So this helps not just by creating a virtual mosaic. One can also select a particular you know layer and then perform the on-the-fly processing, like calculate NDVI and perform any raster function analysis on it. Another is multidimensional imagery. So multidimensional, the term itself is self-explanatory. It deals with time, location, and variables. So variables can be one or more than one. It helps us in performing the complex analysis. So where we can explore the different scientific trends and anomalies. Say we have rainfall data, daily rainfall data. So rainfall is one variable, and with respect to the time, where we also cover the spatial information X5 in that particular image. So this type of imagery helps us to get temporal profile, statistics, geoprocessing analysis, perform the aggregation, find the anomalies, and also do the predictions. So a quick demo regarding this I will show you in a while. So let's also discuss popular image analysis approaches. As we all know, the popular raster functions that we have in ArcGIS are um, mm, and these are on-the-fly processing, which can be performed in desktop or web. And some important raster indices are also available in ArcGIS. Um, there is a change detection measure which helps in detection of change using a pixel, temporal, or categorical change can also be done. An image classification widget is also available, which helps us to either perform supervised and unsupervised classification. Um, so the quick demo regarding this, I have, so this is our ArcGIS Pro interface, where in the imagery layer, we have this change detection and classification widgets, deep learning tools, and these are the RFTs, which I was talking about. And so for this, here I have image for two of Nagpur region, Makar Dokra Dam is present along with the coal mines nearby it. So in this region, what I can do is I can simply perform change analysis using from to and to entering from and to raster, and uh, take pixel value change. So here I have already taken, in the interest of time, I have already performed an NDVI analysis of that particular region. So what this depicts is that over the time from 2014 to 2023, the green areas are where the vegetation indices have increased, and the red regions are the where vegetation has lost. Right. So this was a quick analysis using this change detection widget, and another is the classification which I wanted to show you. So for classification, we have this classification measure. But before that, since I have done the supervised classification here, I had to collect image training samples, right? So for that, what I will do, I will just, I will make my schema here first. What are the classes that I want in this particular area? And then I will make my training samples like this. So after performing this, so after collecting training samples like that, I have classified the 2014 and 2023 region as mine, water body, vegetation, agriculture, and built up. And then what I have done is I have uh, I have found out using this classified image, I have also found out the categorical change detections. So which means that by categorical, it means thematic, which class has been changed to which class value now. Like say mines are converted to water body, and you will also get the attribute regarding this and also the area related to such classes. So say mines and vegetation, mines is changed to the vegetation, so area is this much, right? So in this way, one can also perform a categorical change detection over the classified image and also a simple pixel value change detection using any indices of your interest. And regarding the mosaic datasets and multidimensional, so mosaic datasets, as I was talking about, one has to create a mosaic dataset using this tool. Like you have to create a new mosaic dataset in the geo database. Since I have already added that, and you have to add your rasters using this tool, where you will select different types of rasters. Like if you have Sentinel, you will select accordingly, and then input your file or folder. So, in the interest of time, since I have already done that, I will quickly show you the footprint here. So here in this image, I have added this 10-meter resolution surface reflectance of Sentinel-2 and also 20-meter. Along with that, I have also added the this Landsat 8 surface reflectance file. So in this way, we can have virtual mosaic. It is not mosaicing, stitching the data per se. It is just creating a virtual mosaic. And we can also select an individual type and go to data and their operation and lock to the selection. And by doing so, we are locking our this selected layer, and then we can perform, any analysis. Say I want to perform NDVI. So I will select test and then super and then other. So this will help me. Just a second. So this will help me to create, even perform, after creating virtual mosaic, this will help me to perform even in the selected layers. I can perform my raster functions or any other analysis, right? So this was about the mosaic datasets. And another thing that I was talking about was the multidimensional imagery. So multidimensional imagery is same. We have to create a mosaic dataset for the same, and then we have to add, modify our mosaic dataset by adding the build multidimensional info, where we will input the rainfall as a variable. So after doing that, we can see that we have added the rainfall data all over the world and also we can create the subset out of it, say for Indian region. So in this multidimensional, once you build your multidimensional layer, the multidimensional tab is open here, and you can see all the variables and also the standard time associated with. And we can also see how to make a temporal profile. Say in this particular region or subset, if I want to make a temporal profile of this region, so it will give me a daily total precipitation over the time, right? Similarly, I have also created one aggregate here for the subset, which is a monthly aggregate. So in that case, you will find the variation of precipitation in month wise, right? So in this way, there are different analysis that we can do with the help of multidimensional raster. So now moving back to the presentation. So let's talk about the advanced image analysis using deep learning, right? So uh, deep learning and artificial intelligence has been the talk of the town these days. But there are many challenges that we face, which is regarding the labeling, which is regarding the input data sets. So what is good about the SV and SV India offerings are that we provide some like for the common problems, we provide a pre-trained models so that these are freely available. I will also show you the link of those like how to download your freely available DLPK models. DLPK is the deep learning packages. So these pre-trained models helps us to at least get a base of some deep learning models, and then we can build upon it as per our requirement. So this possibility is there. Another possibility is that we, since it it may happen that our need is very specific. So it may happen that we have to create our deep learning model from the scratch. So in that case, we also have that kind of capability in ArcGIS Pro, which helps us to uh, create our own model. Sorry, uh, create our own model, and then for that we have the process of labeling, data preparation, and then training the model and inferencing into the new regions. So what it does is that deep learning capabilities in ArcGIS Pro helps us to eliminate the extensive labeling requirements, and we have imagery requirements for model training because of the availability of the pre-trained model. And also so a beginner it becomes a beginner friendly too. You do not have to have very good in programming or something, so to be able to achieve your whatever solutions that you want to achieve using deep learning. So there are different workflows of deep learning which is available in ArcGIS Pro, which is say object classification, which helps in assigning a label to a given image. And Another is object detection, which uses models like YOLO, FASTER, RCNA, which helps us in finding the object and their location, and it creates a bounding box on that particular object of interest. And pixel classification, as we also know this as an image segmentation. And so here we assign a label to a pixel where different models like unit classifier, deep lab, etc. are used. So these are very popular for land cover classifications. And instant segmentations, which helps us in finding the object and their precise location and polygons and features. And road extractions, where you can extract road using aerial or satellite imageries. Edge detections, like finding edges, as the name suggests, right? Finding the pixels which belong to the edges. And this uses the models like head edge detectors and change detections, so to identify areas of persistent change, and some image translation methods. So before showing the Living Atlas, I will also like to show you the enhancement that has came in the ArcGIS Pro 3.3 version, which is AI assisted labeling. So here I'm showing you how in any image. So here you can see that it is a JPEG image. I have randomly collected. So I want to label these airplanes. So how to do that? Just using the AI assisted labeling feature that we have in ArcGIS Pro. So here you will see after some time. Uh, it will automatically, just after typing plane here and searching and starting the search, it has detected all the planes, and I'm just correcting whichever is mislabeled here and removing those parts. And so this will provide me, one assistance, a complementary process while labeling. So because labeling is very exhaustive process during a deep learning, so it is very interesting feature that has been introduced with the recent um, update in the ArcGIS Pro. So, regarding the DLPK part, so this is the Living Atlas of ISRI, and once we type DLPK here and search, then we can see different types of deep learning packages. Say land cover classification of Sentinel-2, right? You can directly go to this site and download your deep learning packages and use this pre-trained model for your, image analysis. So one thing that I would like to show you in here is regarding this. Here I have used the TextSam model, which is recently been added. It uses text prompt to detect objects in using deep learning. So here we just have to. I have just downloaded this TextSam model from the Living Atlas, and then input my raster, and then detected objects, and then I will provide the DLPK file here. So as I was suggesting that you should download your DLPK from there. So after downloading that DLPK file, you will enter the, load that DLPK file in the model definition. So like this. And then accordingly, you will get the arguments with respect to the and deep learning models. So in this case, since this is a text SAM, so if I just write plain here and run this, also select my environment as GPU for faster processing, um, and run this thing, then I will get this kind of results by using the text SAM. So there are some misclassification which I can definitely adjust by, tweaking the parameters in here, like overlap and thresholds and all. This is why DLPK is a ready to use pre-trained model is very handy for even beginners. So I will really encourage you guys to try this out, and it will be very effective for your this image analysis processes. So let's move ahead to the full motion video in ArcGIS Pro. So FMV videos are is a situation is came into picture um, for the situational awareness. So here the video is MISB compliant, means that video is having geospatial information and also the metadata. It has the metadata. One can overlay video frames on the map, as you can see here. Um, And also you can pan and zoom all these videos. I'm showing you how to fast forward this, how to, uh, slow it down. And then I'm also showing these are the uh, metadata and the live metadata of the video. And also there is option for bookmarking like this. And you can also perform measurements, say height of the building or uh, anything like electric poles. So yeah, and you can also get the not arrows. You can export it to the metadata to CSV, to metadata to features, and also export this in a chip frame and export this frame in the PPTs, right? And the interesting feature about this is also that you can, on the fly, you can also annotate. Say, if I want to annotate my the number of cars in this region, so I will annotate this car. Okay, just like this. So in this way, um, we can display so in this way it is really very important tool for situational awareness and used by many oil companies and utilities, defense sector, uh, and this also helps in automatic report generation um, in the after all the analysis. Okay, so next, I want to talk about the SAR capabilities. So SAR capabilities in ArcGIS Pro has been there for a while, and it is the level of support is depends on the sensor. Mostly, it is like very friendly with Sentinel-1, ISI, Capella, and Radarset 2 datasets, and the uh, analysis like creating color composites, compute SAR indices, and the new additions like extracting water from the SAR imageries and debursting of if you have SLC data of Sentinel-1 where you want a single file from the deburst. So you can use this debursting method and get a single file from the SLC. Um, and so here I have shown you some clips of how I did the bright object detection in oceans and water extractions, which I will also show you in demo. So let me take you to the demo. So first of all, this is my SAR imagery with both VH and VV band of polarization. So I have created the like RGB composite of it. And then, as you can see, that we have these many SAR related tools. So before, going into the analysis part of the detecting bright object, I have applied the radiometric calibration for this particular region. And then what I did was, and then I have used this radiometrically calibrated data as an input for this. And we will select this depending on the size and of the object that you want to identify there. And also provide a mask feature. So mask feature can be, so in my case, the land portion, I didn't want the land portion. That's why my mask is the land. So I added that as a land, and it's very good to apply a geo correction using your DEM raster. So after doing this, running this tool, I uh, got this uh, output, right? So I got this output, but since it was not aligned, so what I did is that I applied the geometric um, terrain corrections to my calibrated file. So this has helped me to align with the DEM raster, and then I can get all the detected, like the bright objects in the ocean, which are ships in this case, and then uh, by like performing some further analysis, I also tried to find out the density of ship in this particular area, where I have created a grid cell of 2 by 2 kilometers. Now this is giving me that these red regions are having the density of like higher density than the yellowish region, and we can also check its attribute table where we can get the count of polygons in particular grid, right? So in this particular grid, there is 7 ships. So it is giving that is showing me the highest density of that in that particular region. So this was an interesting analysis which I have found. And another is that extract water. It's while extracting water, so it might be very tedious task to extract water from all the small water bodies, including all the small water bodies also. So therefore, there is a direct tool for that using SAR data, where we provide our radar data and which is radiometrically corrected, and provide the minimum area, and provide the DEM raster and run this tool. So this is how SAR has also SAR capabilities is also very interesting in ArcGIS Pro. And uh, so yeah, I'm coming to the end of my session now. I would also like to highlight, introduce you to our next session, which will be on ArcGIS Reality for Photogrammetry, where you will get to know about the reality mapping, which is the process of creating accurate digital depiction of the physical world using images, radar, or both. So we will talk about different ArcGIS reality product suite, like drone to map, side scan, ArcGIS reality for ArcGIS Pro, and ArcGIS Reality Studio.